Hello, this is the Math 1813 Prep for Calc Exam 1 review, Spring 2023. We're going to start in section 1.1, which is function notation. So question 1 tells us to use the function f of x to find each of the following. So f of 5 means that we're going to plug 5 in for x in the formula of f of x. So that means that we're going to be negative 5 squared minus 7 times 5 plus 2, which will be, we can check that with our calculator. I'll just get mine out really fast. To get negative 58. This time we're going to be plugging in the quantity 5 times a in for x. So we're going to get negative 5a squared minus 7 times 5a plus 2. And we can simplify by just squaring and distributing. So we're going to get negative 25a squared minus 35a plus 2. Now the same idea, we're going to plug 5 plus a in for x in part C. So we're going to get negative 5 plus a squared minus 7, 5 plus a plus 2. And simplifying a little bit by foiling, as we now know how to do, we're going to be doing negative a squared plus 10a plus 25 minus 35 minus 7a plus 2. And we can simplify this by combining like terms. I'll brush through that really quickly. So we get minus a squared. We have a minus 10a here with the net minus sign, and we have a minus 7a here, so that becomes minus 17a. Then we have a minus 25 and a minus 35 and a plus 2, so that becomes negative 58 from above. Nice. So that's for question 1. I'll circle these answers to make it a little more clear, since the writing became a bit sloppy. Okay. Now for question 2, so we're given the functions f, g, and h, and we want to answer each of the following. So f is given in a table, h is given in a graph, and g is given in function notation. So for f of 5, we're going to scroll over here to the table, and whenever x is 5, f of 5 is 6. So f of 5 is 6 from the table. H, we're going to use our nifty little graph here. Whenever x is negative 1, we're going to trace the graph. H is 4. And this is, x on the horizontal, y on the vertical. So it's H. G of 3a, we're just going to plug 3a into G. So we get 1 minus 9a minus 18a. And I simplified there in a few steps. But we just plug 3a in here for G. If we want to solve h of x equal to 0, well, if h of x is equal to 0, it means that we're crossing the x-axis in the graph. So that's these 2 points here. So that looks like negative 3 and 1. And for g of x equal to 1, we're just going to do that over here. So we have 1 minus 3x minus 2x squared equal to 1. So that means that, so we can cancel these 1s. So we get negative 2x squared minus 3x equals 0. We can factor it in x. X times negative 2x minus 3 equals 0. So we get x equals 0 as a solution. So I'll write that down. It's a bad 0. There we go. X equals 0 as a solution. And then Over here we also get negative 2x minus 3 equals 0. So negative 2x equals 3, and x equals negative 3/2 is our other solution. 0, negative 3 over 2. Now, for part F, we have how many solutions does h of x equals negative 5 have? Well, we want to set h equal to negative 5, which the idea is h takes on a y value. So we can just go over here and draw a horizontal line, roughly, at negative 5. And we're going to ask how many solutions does h have, or how many times does a parabola representing h of x cross that horizontal line? Well, twice, right? And it's always going to be either 0, 1, or 2 when it's number of solutions, because the horizontal line is going to either cross where it does here, which is during the full parabola, so it crosses twice, or it's going to cross at the vertex, meaning there's one solution, right? Or it's going to cross above the graph or below the graph completely, so there's 0 solutions. But in this case, there's 2. 2 crosses twice. Okay. Let's scroll down. So now for section 1.2, rates of change. The electrostatic force F in newtons between two certain charged particles is a function of the distance d in millimeters between the particles. The relationship is given by the formula F of d is 2 over d squared. We want to find the average rate of change in electrostatic force F on the interval 2 less than or equal to d less than or equal to 4 millimeters. We want to include units and give an exact answer. So basically how average rate of change is going to work is we have two distances, d1, d2. Over the interval, we're going to start at d1 equals 2, and then we're going to end at d2 equals 4. We're going to go all the way across the interval from 2 to 4. The reason I included d1 and d2 is so that we can recognize our average rate of change formula, which is specifically f of d2 minus f of d1 over d2 minus d1. So this is the change in f. Change in f. I'll use y because they're both independent. I'll just draw this back to delta y over delta x. For those of you who remember that. So yeah, okay. So this is our average rate of change formula, and so this is going to be f of 4 minus f of 2 over 4 minus 2, which is 2. Okay, so what is f of 4? Well, we're going to plug it into this equation, right? We're going to get 2 over 4 squared minus 2 over 2 squared all over 2, which is equal to 2 over 16 minus 2 over 4 all over 2. Not to skip too many steps, but since there's a 2 on top for both of these fractions, there's a 2 on the bottom, we can cancel that. So we just get 1 over 16 minus 1 over 4. 1 over 4 can be written as 4 over 16. I'm going to scroll down a little bit, give myself some room. 4 over 16, so get 1 over 16 times 4 over 16, 1 over 16 minus 4 over 16 is minus 3 over 16. And what are the units? Well, the units on top is newtons, and the units on bottom are millimeters. So we're going to get Newton per millimeter. Negative 3 over 16 Newton per millimeter. So that's section 1.2, and in our next video, we'll cover the rest of section 1.2 and the rest of this review.
So for question 4, it says calculate the average rate of change for the function 5 over 2 times x plus 3 all squared for each of the following intervals. Right, so the average rate of change is the same as the slope. So for this problem, we're going to be utilizing the change in y over the change in x. So we have the x values, that's our endpoints. So we have negative 5 and 1. So we need to find the y values by just simply plugging it into the equation. So for negative 5, we have 5 over 2 times negative 5 plus 3 squared, and that's equal to 10. And then 5 over 2 times 1 plus 3 squared, and that one is equal to 40. And now we'll use our change in x, so 40 minus 10 over 1 plus 5, because that's a double negative. And that will equal 30 divided by 6, which is 5. So the average rate of change, or the slope of those 2 points, is 5. So for this one, we got negative 3 and 1 this time. We already know what 1 is from the previous problem. It is 40. So we just have to find one more. Squared. And this point, since this is 0, is going to be equal to 0. So using the same formula here, we will use 40 minus 0 over 1, double negative again, so it's a plus. 3 is going to be equal to 10. And the next one, we have negative 1 to 1. And so let's plug in our negative 1. We're going to know what 1 is from the previous 2 problems. So negative 1 plus 3 squared. So that is equal to 10. So So we do the same thing, 40 minus 10 over 1. Double negative again, plus 1. And this one is going to be equal to 15. Right, so those are all the slopes, and we can see that by kind of graphing the line here. All right, this line is going to have a bigger slope than this one, because it's, and this one. Right, so the steeper the slope, the higher the number. Negative 1 has the steepest slope, negative 3 has the second, and C has the flattest slope, so, or A has the flattest slope, so those lines check out. All right, next problem. Number 5, find the intervals over which the function is increasing or decreasing. Use interval notation. Right, so we're going to look at our graph over here, and everywhere where the y values get smaller, that's where it's decreasing, and everywhere it gets bigger, it's increasing. Right, so this here is going down as we go to the right, so that's decreasing there. Here it's going up, so it's increasing, and here is going down. Right, so however, at these points here, they are not increasing or decreasing, they are flat. The slope is 0. So that means they're not increasing or decreasing, and that just means we're going to use parentheses instead of brackets. Right, so it's only increasing from negative 5, right, in the middle, right, so we have 3 sections, and it's only increasing on section 2, which is from negative 5 to 3. Then it is then decreasing on 1 and 3. So from negative infinity all the way to negative 5, it is decreasing, and then from 3 all the way until it ends at infinity, it is increasing, or it is decreasing. So that's number 5. Then number 6. A bathtub is partially filled with hot water when the cold water tap was open. 2 minutes later, the bathtub held a total of 48 gallons. 5 minutes after turning on the cold water, the bathtub held 61.5 gallons of water. What is the rate of change of the water from minute 5 to minute 2? Right, so we know 2 things. At minute 2, we had 48 gallons. And then we also know at minute 5, we had we have 61.5 gallons. So, with those two things, we have our x values here is time. Time is almost always your x value. And time is affecting the amount of gallons in the tub. So that's going to be your dependent variable or y variable. And now, right, our average rate of change, or our rate of change is equal to our slope. We can use our slope formula to find what the average rate of change is. So we have, here we have 61.5 gallons minus 48 gallons all over, and you have to be careful. Since 61 was first, we have to do 5 minutes first. So 5 minutes minus 2 minutes. And then we're going to put this in our calculator. And get 44.5 gallons per minute. Right, part B. So that's part A here. Part B. How many gallons were in the tub when the cold water was turned on? Well, we know that at time 2 minutes, there was 48 gallons. And we know that every 2 minutes, 4.5 gallons per minute is added. So, we can find out how many gallons were in it before. So if I just multiply this by 2, 2 minutes, right, that means we'll have 9 gallons because these minute units will cancel. So that means in 2 minutes, 9 gallons were added. So if at 2 minutes there was 48 gallons, that means at 0 minutes, we can subtract them. And that will give us 39 gallons. So that means 39 gallons were in the tub before. Right, now write a linear function for n gallons of water at t minutes. So we go to our linear slope equation, y equals mx plus b, and we know what y is. Y is going to be n, the number of gallons. M is our slope, which is going to be 1.4. X is going to be our minutes and time, and t plus b, our y-intercept, which is the amount that the tub started with, which is 39. So this is our equation for part C. And that is our answer. For number 7, it says a plumber charges according to the formula C of T is equal to 150 plus 90T, where CT is the charge in dollars for working T hours. Identify the vertical intercept and the slope and explain their meanings. Well, I know that C of T is equal to dollars. And if something equals dollars, that means each component has to equal dollars. So that means this also has to equal dollars. And we have this T here. And that T is in hours. So in order for this to add, it has to be in dollars too. So that means 90 is going to be in dollars per hour. So that when you multiply together, you just get dollars. Okay? And so that means that this is our vertical intercept and this is our slope because it's connected to the T. And this is a lone number. So our vertical intercept is equal to $150. and our slope is equal to $90 per hour. And then it says explain their meaning in practical terms. So if this is a plumber charging for his work, that means that the vertical asymptote, or the vertical intercept, if he worked for 0 hours, you'd be paying him $150. That means that is his fee, his starting fee. That means you're paying him additional for just fees for construction material, whatever. Then the slope is his rate. He then works for additional $90 per hour. So he works for a flat $150 plus his wage. So then he works for $90 an hour. So this is his wage. All right. So question 8: find the equation of the secant line that passes through this equation, -1/2 x minus 2 squared plus 1 at 2 and 4. So a secant line is a line that passes through 2 points in the graph. So as shown on this graph, we have here, which I'm going to assume is 2, and here, which I'm going to assume is 4. So 2 is going to be a positive number, 4 is going to be a negative number. This is the secant line here, the 2 points, so that straight line. We can also call it the average rate of change. So if we find the slope of the secant line, well, we can find the equation for it. So let's start by plugging in 2. So f of 2 is going to be equal to -1/2 2 minus 2 squared plus 1. So this is equal to 0. So that means that this is equal to 1. We do the same thing for 4. Oh, sorry. I don't know what that line is. F of 4. Same thing, plug in 4 here. 4 minus 2 squared plus 1. And that's going to be equal to -1. I'm going to just check that. Yeah, so 1. Or -1. So we have our 2 points. We can now use our slope equation, delta y over delta x, which is equal to our y values. So we have -1 minus 1 all over 4 minus 2, right? Because we have 4 and 1, or -1 and 1 and 2. So that means that this is equal to -2 over 2, which is equal to a slope of -1. Right. So we have y equals mx plus b, our slope equation. Right, so now we know the slope. Do we know our x and our y? Yes, we do. We have 2 points. We can use x equals 2 or x equals 4. I'm just going to use 2. So that means that our y is 1. Our slope is -1 times 2. And we can find b. So that is 1 equal to -2 plus b. Add 2. And we have b is equal to 3. So our equation for our secant line is -1x plus 3. All right, number 9. Find each of the following for the function shown below. Part A, -3. So we don't have a function, we just have a graph. So I'm going to go to my graph and I'm going to go to -3. I'm going to go up, and I see it's right here at the start of the line, and I'm going to go over, and it looks like it's about 8. So I'm going to say f of 3 is equal to 8. I do the same thing from 0. Here's 0. So I'm going to go down, and it looks like it is at negative 10. Right? So for what values is x equal is f of x equal to 0? Right? So I know if f of x equals 0, this is the same as y is equal to 0. So I'm going to go to my y-axis where y is equal to 0, and I'm going to go over, and I see here's 1 here at negative 2. So x is equal to negative 2. And I'm going to go this way here, and it looks like that's happening at 5. So x is equal to 2 and 5. What value is of x is f greater than 0? Right, so I'm back at my line here. I have my line here that y is equal to 0. So here I want to know where y is greater than 0. So everywhere above this line, we're looking. And so we start here, right, at negative 3. This part is greater than 0, and that goes all the way to negative 2. So I'm going to write that negative 2, and 0 isn't greater than 0, so that means we're not going to include negative 2 because it is equal to 0 at negative 2. But everywhere before that is. So, and then I'm going to union. I'm going to go back to my line. I'm still negative down here, all the way past that, and all the way here. I'm negative until I get to 5 again, where I am now back to being at 0. We use my parenthesis because 5 is equal to 0 and not greater than 0. And that's going to go all the way to my end point, which looks like to be 7. Oh, however, if I look back, at my point negative 3, I can see that that point is open. So that means 3 doesn't exist in this. So that means that 3 is going to be a parenthesis also, and 7 is going to be a bracket, because that is a whole point. There we go. So, what are the domains and ranges for this function? Use interval notation. Well, so our domain is everywhere that x exists. And if we look, so we're starting at 3. I see that it can be everywhere on that line all the way until it gets to 7, and then it stops at 7. And everywhere in between negative 3 and 7 is a point. So I'm going to say, since negative 3 is an open circle, from negative 3 to 7, the domain exists. And then for the range is the range of our y values. So I see that here at negative 3, it starts at 8, and it goes down all the way to this point here at what looks like to be about negative 12. And then at negative 12, it starts to go back up all the way at 7, where it is at 18. So that means our bottom value is negative 12, our top value is 18. Both of those values exist, so we can use brackets. Our range is negative 12 to 18 with brackets. For number 10, suppose f of x is equal to 3 minus 1 squared. Find f of negative 2h minus f of negative 2, all divided by h, where h cannot be 0. Simplify completely. All right. Well, first, I'm going to find f of negative 2 plus h. So I'm going to come here, so 3 times, and then this is where I plug in my x here. So I'm plugging negative 2 plus h minus 1 squared. And then I'm going to rewrite this as 3 minus 3 plus h squared. And then I'm going to FOIL it. I'll write it out. Negative 3 plus 3, negative 3 plus h. So I now have 3 times 9 minus 6h plus h squared. And then finally I'm going to multiply it all by 3. All by 3. And I get 27 minus 18h plus 3h squared. Now, so that's this part. I'm now going to do the same for f of negative 2. And that's going to be a lot easier. Because I can just, squared. And so this is equal to 3 times negative 3 squared, which is equal to 3 times 9, which is equal to 27. So now I'm going to plug that into my big formula where I have 27 minus 18h plus 3h. So I'm going to plug this into here and plug this into here. So I have that. So I have the first part, f of negative 2 plus h, and then minus 27 all over h. And now I'm going to simplify. Here I have negative 27 here, and I have 27 here. So these are going to cancel, and that's going to leave me with negative 18h plus 3h squared all over h. And since each term has an h, I can take an h out. So I'll get negative 18 plus 3h all times h over h. And these will reduce. So my final answer will be negative 18 plus 3h.